Hello everyone, welcome back to my YouTube channel. This is my second video for data structure and algorithms presentation. Today I am going to present about Tower of Hanoi, which is famous mathematical puzzle and important concept in computer science. This puzzle is mainly used to understand recursion and logical problem solving. Even though it looks like simple, it teaches us how complex problems can be solved step by step using smaller sub-problems. So let's see how Tower of Hanoi works. Hello everyone, a warm welcome to my presentation. In this presentation, I will explain how the puzzle works, the rules behind it, and demonstrate a simple 3-disc example step by step. I hope you enjoy the presentation, so let's get started. The Tower of Hanoi is a classical puzzle invented by Edward Lucas in 1883. It contains 3 rods: source rod, auxiliary rod, target rod. There are multiple disks of different sizes stacked from largest at the bottom to smallest at the top. The main objective is to move the entire stack from the source node to target node while following specific rules. The rules are: only one disk can be moved at a time. Only the top disk can be moved. A larger disk can be placed on a smaller disk. This puzzle is widely used to teach recursion in programming and computer science. The objective of the Tower of Hanoi is simple. We need to move all the disks from the source peg to target peg without breaking any rules. At first, this may look difficult because the disks are arranged by size. But the following systematic process, the puzzle can be always solved. This problem helps us improve logical thinking and teach how to solve large problems by dividing them into smaller steps. The most important concept in the Tower of Hanoi is recursion. Recursion means a function solving a problem by calling itself repeatedly with a smaller version of the same problem. The recursive solution follows 3 main steps. First, move the top n-1 disk from the source peg to auxiliary peg. Second, move the largest disk direct from the source peg to target peg. Third, move the n-disk from the auxiliary peg to target peg. This process repeatedly until only one disk remains. That smaller problem is called base case. This is why Tower of Hanoi is considered one of the best examples for understanding recursion. Now let's look at a simple example using 3 disks. Initially, all the disks are stuck on a peg A, and the goal is to move them to peg C. The solution requires 7 moves. The moves are: move 1 small disk from A to C, move 2 medium disk from A to B, move 3 small disk from C to B, move 4 large disk from A to C, move 5 is small disk from B to A, move 6 is medium disk from B to C, move 7 is small disk from A to C. After these 7 moves, all disks are successfully moved to peg C in the correct order. This example clearly shows the how recursion works step by step. Now I will demonstrate the Tower of Hanoi using 3 disks. Here peg A is the source peg, peg B is the auxiliary peg, and peg C is the target peg. The goal is to move all disks from peg A to peg C while following the rules. Move only one disk at a time. Only move the top disk. Never place a large disk on a smaller disk. Let's begin. Now I move the small disk from peg A to peg C. I move the medium disk from peg A to peg B. Next, I move the small disk from peg C to peg B, placing it on top of the medium disk. Now I move the large disk from peg A to peg C. Next, I move the small disk from peg B to peg A. Now I move the medium disk from peg B to peg C, placing on the large disk. Finally, I move the small disk from peg A to peg C. Now, all the three disks are successfully moved from peg A to peg C in the correct order. Now, I will demonstrate the Tower of Hanoi concept using kitchen plate as a real life examples. I have three plates of different sizes. This large plate represents the largest disk. This medium plate represents the middle disk. And this small plate represents the smallest disk. Just like in Tower of Hanoi, these plates are arranged from largest at the bottom to smallest at the top. My objective is move the entire stack from this side to other side while following the same rules. First, I can move only one plate at a time. Second, I can only move the top plate. And finally, I must never place a large plate on top of a smaller plate. At first, this may look simple, but when we follow the rules carefully, we can see that the movements must happen in a specific order. Now, let's start the demonstration. First, I move the small plate to empty side. Next, I move the medium plate to the target side. Then I move the small plate on top of the medium plate. Now the large plate becomes free. So I move the large plate to the target side. Next, I move the small plate back to the starting side. Then I move the medium plate onto the large plate. Finally, I place the small plate on the top. Now the entire stack has been moved successfully while following the all rules. This demonstration shows how the Tower of Hanoi solved a large problem by breaking into smaller steps. The number of moves required in the Tower of Hanoi can be calculated using 2n-1. Here, n represents the number of disks. For example, 3 disks needs 7 moves. 4 disks need 15 moves. 5 disks need 31 moves. We can see that the number of moves increase very quickly as the number of disks increase. The time complexity of the algorithm is exponential, which is written as 0 of 2 power n. This means the problem becomes much more difficult for larger number of disks. Alright everyone, that brings us to the end of the Tower of Hanoi. To conclude, the Tower of Hanoi is not just a simple puzzle. It is a powerful example of how recursion works in a computer science. It shows us that even a very complex problem can be solved step by step, breaking into smaller, easier subproblems. I hope this helped you understand concept more clearly. Thank you so much for watching. Have a great day. Bye bye.